All right, we'll get started. Good afternoon, everyone. Welcome to the final session of this year's first ever virtual safety conference. I know the last session on Fridays, people are always itching to get out, so we'll make sure we're done on time so you could stay home and basically go nowhere after this is over. Today's session topic is technology and design for an uncertain future. We have two topics and two presenters. They're both going to be presenting the first topic, and then Steve will be presenting the second one on his own. So I'm going to do the introductions of the speakers now, and then we'll get started. So our first topic today is traffic in the COVID world. And the two speakers for today will be Ryan McNary. Ryan oversees PennDOT, oversees several PennDOT systems that support 24/7 traffic management. This includes our advanced traffic management system, road condition reporting system, 511 PA, Genetech, which is our statewide video solution, traffic alerts dashboard, which is crowdsourced incident data. So a whole host of things that Ryan's responsible for. Ryan also leads the department's TISMO performance management efforts, where they've successfully linked several PennDOT data sets to crowdsourced big data. In January this year, the PennDOT TISMO Performance Program released the first data-driven PennDOT-specific congestion pie chart. Ryan began work for PennDOT 13 years ago, has a bachelor's in geography and planning from Westchester University. And our second speaker for today will be Steve Galt. Steve Galt strives to ensure smooth mobility throughout Pennsylvania with new approaches to using technology to safely and efficiently move humans. As PennDOT's chief of TISMO arterials and planning, Steve uses his passion by overseeing traffic signals, arterial operations and planning for deployment of TISMO solutions across the state. Steve has been testing the limits of traffic signal controllers for several years, including building his own software to analyze controller log data. He's a licensed professional engineer in Pennsylvania and certified professional traffic operations engineer. And over his shoulder, you can see some of his own handiwork in the house. So our second topic, first topic again, will be traffic in a COVID world, and then we'll be transitioning to traffic signal remote communication and detection. So with that, I will turn it over to Ryan and Steve. Gentlemen.
Thanks, Doug. Thanks everybody for being here on Friday afternoon. Appreciate that. So let me get my screen shared here. So I've noticed on the agenda in some of the sessions that we've been sitting in the last couple of days, a lot of COVID talk. We're going to talk a lot of Pennsylvania specific kind of responses that we did back through March, some of the district actions, and then some outcomes and some decisions that were kind of posed to us going forward. So the agenda for today, kind of already alluded to what we've done, what we've addressed, some critical needs, some traffic volume data visualization. So we, as Doug kind of did in his introduction, my office oversees the TISMO performance program. So we have a big, large database. It's around 40 terabytes of information, whether it's the DOT or it's crowdsourced data from our vendors that we have correlated. So that's given us the ability to look at some of this information.
You're not sharing it if you think you're sharing here.
How about now?
There you go.
Sorry about that. Well, we didn't miss anything. But anyways, the agenda, Steve's going to go over a policy that we put into place. And then going to get into some perspectives about the Pennsylvania trends, some national trends, and then talk about fuel tax revenue. I know that's a poignant topic of conversation that we've talked about a little bit, but we'll just give you a little bit of what our office looked at. So in the inception of this, back in March, when we went through this effort, we started a relationship with the Bureau of Planning and Research to get access to the permanent traffic count station data. What we wanted to understand is a relationship to the 2019 traffic counts to the 2020 counts we were understanding. So coming from Doug and our leadership from Highway Administration, we had to have this ability to look into this so we can make responses. So as you're aware, and the Secretary spoke on the first day, we ceased all construction back in March. But when we were starting to go through the process of kind of turning it back on per se, we had to look at all these different aspects. So you can see there are some quotes from our DTEs who were receiving a kind of report for Mondays and Wednesdays, 2 times a week since March. We've been doing that. So our office, so the highlights you can see there, it gave trends for an overall, but we had the actionable responses from the governor's perspective, but then we put in differences. Now the color coding you can see there on the right were the actual government responses. So we went from the red, the yellow, and the green. So you could see those visually as we went through. But this, from our perspective, was kind of a success, and they appreciated it from our traffic engineering perspective. Some of the adjustments and actions that were done by the districts when we started to look into having construction resume back in May. So they looked at different restrictions. So construction day of week and time of day restrictions. They looked into the reevaluation of the highway occupancy permits and the traffic impact studies. They adjusted the staging areas, for example, and then the traffic control plans and how they would potentially, with the lower volumes, they might not have to have as such a rigorous traffic control plan. But this also spurred the kind of reinvestigation into our permanent traffic counters by our districts. What kind of brought it to light is we don't have them on some of our core routes, for example, I-95 in Philadelphia. So District 6, for example, and I think District 11 started to look into some other routes where they'd like to have permanent counters. So there's a partnership again with the planning organizations and our districts, and then our Bureau of Planning and Research to potentially look into adding more permanent count stations. To kind of follow up with that concept, we found that this data set is a very good representation of what is happening throughout Pennsylvania travel in general, and we'll get into that in a little bit. But this also was used for a lot of responses for the press. A lot of the information that you saw going on to the Philadelphia Inquirer, or for example, local, more regional news agencies was received through our office, and most recently we transitioned over. So what we did with all this is we wanted to make a tool, kind of going back to the TISMO performance program. We wanted to make a tool where we could kind of get out of the business of creating an Excel spreadsheet 2 times a week, but also empower our districts and our users to have the ability and some flexibility to look into the data on their own. So Steve's going to be going over some specific examples of this for you all, but I kind of wanted to do the first introduction for everyone here on what the tool can actually do. So one good thing about being virtual, I can pull this right up on my computer right now. So what you're looking at is the real data. Now this is in the dev environment, so we have it through October right now, but it gives you the filterability to look at specific districts, your type of roadway access, so limited or no access, county, road specific information. But you have the ability to go day a week. You can do your peaks, for example. But then, so this is, I gotta make that smaller. 1 second. I'm just gonna do something real quick here. I'm gonna do passenger vehicle only. So you can see here that the lines in blue are your 2019 counts. The bars are your 2020 counts for passenger vehicles on your permanent count stations. So you can see when the impact occurred in real time, and then you can actually go and to see where we are. But we have the ability to drill down now. So we can get into days of week. We can look into certain vehicle types. We can look at a personal type of hour. So we get into these comparisons year to year. We hope to make this available here within probably the next month or so to all the districts. We're working on kind of the refining when we can release the actual data with the Bureau of Planning and Research. But this is, I just wanted to give everybody a first look of the interactive tool that we want to make available for everybody to make those engineering decisions from the district perspective that I talked about before. So that's some of the stuff we did in the beginning as far as switching over to a response to make actionable decisions. But going into Steve's slides, this happened in April as well. And I'm going to let him go over some of the information that he dispersed to his office, from his office, sorry.
Thanks, Ryan. So as we started to see the restrictions come into place, and we knew that everybody we knew for the most part was not commuting to work, we knew there was a big change to volumes even before we started to quantify it. So as we look at how that impacts the different types of analysis that relies on traffic volumes that we do, we recognized there was a need to change our normal business practices, and therefore we issued a strike-off letter in April that applied to really all types of transportation studies, from HOP transportation impact studies to DM1 studies to even just simple traffic control studies with a TE form or traffic signal timing analysis. And the intent of this was to apply engineering judgment, figure out, is there a way we can predict what volumes might be in the future, and see what we can do to account for those changes that were happening. Recognizing that we really don't know what the future is going to be, we suggested for HOP applications, we didn't want to hold up the progress of those applications, so therefore we talked about in the strike-off letter doing post-development studies to then confirm what the impacts are and make some tweaks, but also understand that we can't just have an open checkbook for all sorts of improvements down the road. So we really try to limit that to when we know that we're generally close enough geometrically to the right number of lanes and so forth, but maybe we need to tweak some signal timings after the development opens and after all the restrictions are lifted. So that's where we started with from a policy standpoint, and then we've been monitoring things since then. So if you want to go to the next slide. This shows, again, this is kind of similar to what Ryan was showing with that dashboard a few moments ago. But when the restrictions started happening and non-life sustaining businesses were closed, there was a rapid reduction in traffic volumes. And this, there was a publication that came from ITE a few months ago that looked at some of the trends, and I looked at that from the Pennsylvania perspective, and we really were seeing a very similar pattern to what was happening nationally, with a rapid reduction, and then things started to stabilize a little bit. Things were gradually starting to figure out how can we continue to live life and do business and stay safe. So there was some things that reopened. In Pennsylvania, that was the yellow phase. And we saw a gradual increase. And then once we got to the green phase, then we started to somewhat level off. And it's important to recognize that the difference between last year and this year, there's always seasonal variation. So this particular chart shows every Wednesday from March until December. And, so we'll see, okay, there's a Wednesday that's right around the 4th of July holiday. There's some things that may happen there. We see the Wednesday before Thanksgiving is typically a larger travel day. But yet we've been pretty consistently about 10 to 15% down on a daily standpoint since July when all the counties were back in the green phase. So Ryan, you can go to the next slide. So what's really driving this new normal, and how do we figure out, is this 10 to 15% things that are going to continue indefinitely, or are they things that, because there's still some things that aren't fully open, are they things that are going to come back? So we've certainly seen an increase in work from home and the corresponding decrease in traffic from that, which I'll focus on a little more. But even at a retail level, people are getting a lot more things delivered to their homes. So we may see more last mile freight deliveries than we had seen in the past. Schools are operating differently, both at the K-12 level and also universities. Some of the recreational trips that were happening over the summer, people were still trying to do a summer vacation, but doing it closer to home, driving instead of flying. And then some of the things that people really can't do as well and maintain social distancing. So we see a shift away from for mass transit usage and ride sharing and probably more single occupant vehicles because of that. So a lot of different dynamics that are all happening. It's hard to really quantify exactly how much each one is impacting where we are in aggregate, but they're all contributing to what we know is happening. So the work from home, ITE had looked at some information and said historically the census shows that about 5% of people were working from home and considered that to be their commute trip. If we got to a point where in a post-COVID environment, some of that work from home continues, even if that doubled from 5 to 10%, that could have a pretty significant impact on traffic volumes. But it's also important to recognize that work from home is not a one size fits all. And some people, maybe entirely working from home during the pandemic, maybe will stay that way. Some people may be alternating certain days of the week or certain days of the month, and understanding, who's working when is really going to change our perspective on when people are traveling and how we have to design our transportation system to accommodate those users. So when we look at the distribution of volumes, this shows in April when we were at the height of restrictions, very much shut down across Pennsylvania. So this shows Interstate 83 in York County, and we saw very large drops during the morning and afternoon peak periods, 50% or more. The midday was also down 35 to 40%. So, pretty significant across the day impacts. If you go to the next slide. As we come into August and we look at a commuter area, this is Route 581 on the Capitol Beltway near Harrisburg. And during the middle of the day, by August, we were pretty much back to normal. About a 0 to 5% drop in traffic volumes, but relatively close to normal. Same thing overnight hours and other off-peak hours, but those commuter peaks, the morning and the afternoon commuter peaks were where we still saw the significant drop. So when I mentioned earlier that in total we're down about 15%, it's really the AM and the PM peaks that are driving that. If you go on to the next one, when we look at weekdays at a statewide level in August, we can see that it's a little bit more spread out. The midday has some areas we're down a little more than the example I had shown, but we do see that AM and PM peak drop more significantly than other parts of the day. And this is looking at that same section of I-83. Pretty similar pattern here, not as exciting, but certainly a lot different than what we saw in April. And the last example is I-80, and this is looking at I-80. There's a couple different stations across Pennsylvania, but generally I-80 is more of a freight corridor than a commuter corridor. And because of that, first of all, even last year, there really wasn't much of a morning peak, and the volume just gradually builds throughout the day before hitting a peak in the afternoon. But because that freight volume is really much closer to normal than the passenger volume and the commuter traffic, we're seeing that it's a small drop throughout the course of the day, but we're not seeing that same large drop during the peak hours. So as we do those predictions and we try to come up with some sort of a factor to see where we are and if we need to project future volumes, these types of distributions are important to consider as we do that. And understanding that risk, there's locations where maybe we have, where the volume is low and the types of facilities that may not be operating, there's not as many. It's probably an acceptable risk, and we can make reasonable projections for the future from that. However, in locations where the volumes are high, we're closer to hitting capacity and having an oversaturated condition, where there's more businesses that aren't fully operational, schools maybe not in session. Those are the ones where we really need to think more closely about how we make future projections and understand that there's a much larger risk with those projections. And I think with that, Ryan, I'll turn back over to you to talk about the fuel tax.
Appreciate it, Steve. So I said this kind of in the introduction. A request bounced around in the DOT a little bit to look into potentially projecting or coming up with a model based off of the information we have. So Doug kind of implored us to kind of figure this out. You know, we brainstormed, and I believe, Doug, and you think you gave us 24 hours to do this. So we came up with what you see in front of you. Now we looked at our data sources and what we have. So we did partner with the Department of Revenue here. So we were able to get the gallons of gasoline and diesel that were sold. We know our tax rates for both. Second highest in the nation. I think we're all aware of that. But then at that time, INRIX was also supplying a COVID percent BMT estimate, and I believe Streetlight was at the same time too. But what we've done since then and creating that is kind of prepare a report, monthly report for projections based off of all the information we have, whether it's coming from the Department of Revenue or what we're seeing in our permanent count stations or what INRIX or Streetlight is reporting. And then we can project the upcoming month's revenue. What our outcome was is we've been within 3% kind of variance, plus or minus. So that's pretty good, we thought. But what you can see in the spreadsheet below are some numbers that we were pulling together. So we're constantly trying to understand which is the best data source. Because like I said, this was a model that we developed in around 24 hours. It's been a constant evolution, don't get me wrong. But we're looking at our INRIX normalized data, our INRIX seasonal data, because they actually adjusted that throughout their process, 2 different data sets they supplied. But then we were comparing it to our PennDOT core network stations. What we've come to conclude, probably within the last month or so, is that our core network stations are the best representation. A lot of INRIX's information is based off of probe data, where we have actual counts. We take the actual counts from just our core network. So our core network is the 4,000 miles of roadway. So our limited access roads, major arterials, roughly 10% of what PennDOT manages. And it's come within 1 to 2% of the actual revenue that we've experienced, and then the miles traveled. So that's kind of what you see in the spreadsheet below. But through the end of in the height of all this situation, I'll call it a situation, the COVID response, we saw those major drops, and it's a direct relationship to the revenue that you heard from the secretary on Wednesday. Kind of moving back to what Steve talked about is the new normal. What's driving this new normal? We don't really know. And honestly, it's because we don't have a great data set that tells us the who, where's, whens, and whys. So we're investigating potential traffic data to improve that and answer those questions. So this kind of brought the origin and destination data concept back to the forefront again to understand who's moving now, where the commuter traffic is going. Put those hypotheticals to bed. It could potentially do that. It is roughly around, in INRIX, for example, roughly around 3 million trips per day. Streetlight also offers this information. And primarily in Pennsylvania, a lot of our planning organization districts for major construction projects are already buying this to look at traffic impact studies. For example, if they're going to be taking a lane or multiple lanes on our interstates. So we have an ongoing conversation right now with our program center. So it's a planning oriented office within PennDOT to maybe look into procuring a statewide license for this, but that's foresight. You heard the funding issues. We're probably not looking into new data soon, but if we can answer some questions here, it might be valuable. We have the number of existing DOT use cases elaborated on the bottom. I talked about the long range plans, but Steve kind of talked about earlier the consistent design plans. This has kind of immense possibilities. So it wouldn't just have to be those construction projects that are large and they're going to take one route on our roadway. We could actually offer this data to maybe smaller construction projects, so they could do a better analysis pre and post, for example, where we could have a better impact to the motorists and everybody in Pennsylvania. and not have to do it after fact. But signal timing, Steve's love, it would certainly give him a lot of turning movements. We could do more predictive performance analytics, and then we could refine the fuel tax and the volume from probe data. So it's another initiative we're working on right now from our office's perspective. We're trying to get real-time volume so we can make more definitive and predictive operations decisions. So that's a lot of what we've done since March when it comes to volumes and working with our Bureau of Planning and Research and their permanent account stations. So I guess, Doug, we're probably taking questions at the end, but wanted to thank everybody for having us.
We'll do them now. There's two questions that came in. So was planning and research setting manual counts during the time frame? And if so, how is that information being used with the stuff in your program?
Planning and research setting manual counts during the time frame?
Correct.
We did not use the manual counts. We only used the permanent count stations. So the permanent count stations were out there. We didn't use any of the temporary counters for our analysis. I think that's what the question they're asking.
I believe so. And you talked a little bit about it from the funding analysis about using the permanent count information. One more question. For I-80, did truck traffic increase during COVID, resulting in the overall volumes being closer to normal? So I know from the info that you developed for the DTEs, we have roadway by roadway. Can you just offer any insight on what's going on Interstate 80?
So Steve, do you want to take that one or?
Yeah, I think I don't have the numbers for I-80 specifically in front of me, but I know on the fuel tax slide that Ryan had up, as I saw that question come in, it looked like in July, June, July, and August, the fuel tax revenue was actually up about a 1 to 3% statewide. So I think that's a sign that the truck volumes were up slightly. The passenger volumes were down in that 15% range statewide, and that's kind of where we've been relatively consistently for a while.
So I pulled this up for you real quick so you can see this is actually the truck comparison, the blue line again being 2019, the bars being 2020. You can see it almost mirrors each day. So what we found when we were doing the fuel tax revenue, that the truck volumes were averaging around 95 to 103% above the 2019 volumes. So they did go up, I believe, in July. And I think that was in their question, but I'll have to look back, but I do believe they were higher some of the months as far as the numbers and the counts that we saw in previous years.
It looks like there's a couple pink bars that go above the blue line on the,
yeah,
like even in October. So, you know, not consistently higher, but there are some cases where the truck volumes have actually been higher.
All right, that was all the questions that came in. So if you want to move to the second presentation, Steve.
All right, let me bring that up. So taking this concept a little bit further, I talked about volumes, and really as we start to think about, you know, this has really changed the way we've always done it. So the traditional process.
You're not sharing if you're trying to share?
Oh, hold on.
It wasn't just me.
I was going to ask you.
I did the same thing. I had the box highlighted and forgot to hit share the second time. Can you see it now?
Yep.
Okay. So the traditional process for traffic signal timing started with turning movement counts, and then from there we go to modeling and optimization, typically using synchro. And then at the end, we get a level of service. And we can think of that as our measure of effectiveness. And for traffic signals, the level of service is based on the control delay per vehicle. And even though what constitutes the appropriate measures of effectiveness have already been evolving for the past several years, the COVID-19 pandemic provides new reasons to rethink our approach. So thankfully, we have the technology that can allow us to more effectively operate and time signals while keeping us all safe. So I talked about that traditional traffic signal process, and its reliance on the manually collected turning movement count data. And the underlying assumption is the counts were done on a typical day. And that typical day is really the key thing. So historically, we assumed, maybe a Tuesday, Wednesday, Thursday were typical days. But imagine if a weather forecaster just picked a typical summer day and recorded the temperature because he thought it was somewhere between 4 and 6 p.m. Those aren't hours we use as traffic engineers, right? And said the temperature applied all day long and plan what to wear based on that forecast. So will you freeze in the winter? Well, of course, but why was this ever considered acceptable for traffic? And if the traffic volumes were actually that predictable, then why are we spending millions of dollars trying to improve traffic signal operation and putting in technology and adaptive signals and all these things to account for variations? Well, that typical day assumption was pretty weak before, but the pandemic has dramatically changed traffic characteristics, and we haven't had anything close to a typical day since March. So I talked a little bit about this before, the strike-off letter, and we recognize that uncertainty and the need to apply engineering judgment, but the big challenge for all of you is deciding how do you apply that engineering judgment. So with historic data, it may be possible to predict traffic volumes with traditional methods, but there's still uncertainty because we don't know what the new normal will actually be. And what we really need is a way to make our transportation infrastructure operate with varying demands as efficiently as possible. And that's where traffic signal communication and detection come in. So we can think of traffic signal operations in a hierarchy in terms of how much operators are involved or intervening in the operation and how much the current traffic conditions or demand are considered. So at the most basic level, we have a pre-timed signal. It's just running a plan based on time of day with no regard for actual volumes. And we can move up when we can add actuated control and consider at the intersection level some amount of demand and vary the volumes within between a minimum and a maximum. And then we can start to link signals together with coordination and provide a cycle offset and split to keep things synchronized and try to move traffic along a corridor. We can get more advanced technology such as adaptive signals and get more advanced in how we pick things. And then the one I put at the top, and this may sound a little strange, but I put manual control at the top because that's really the point where, it could be something like an operator that's picking the timings for a specific event. So there's a lot of manual intervention, and it could even be using a pickle switch to manually advance the traffic signal phases based on live demand. So all of these require some combination of a controller, detection, either a master controller or server, and communication. And with all four of those components, they give us the most flexibility with what type of operation can be implemented at any given time. So when we want signals to work together and be synchronized, we typically call that coordination, and it involves the cycle offset and split at each intersection. And there's different ways to pick what plan is going to operate at any given time. So all of these are, it's important to make sure that the clocks have to be synchronized for this to work. The simplest method is a time of day schedule, which we have all over Pennsylvania, where the plan is predetermined based on the time of day and possibly the day a week, or even the day a month. The schedule can then reside in each controller, and it's being picked based on the schedule that's in the controller. It could come from a master controller, or it could come from a central server. Traffic responsive operation expands on this by selecting from predefined plans based on some sort of threshold of volume and occupancy from system detectors. And finally, a manual command is just saying, run this immediately, and this is the plan we want to implement now. So central systems allow an operator to remotely monitor and operate signals. And historically, PennDOT implemented a variety of central systems with some examples shown here based on municipal preferences and/or the low bid on a specific project. And here's an example of what happens when we have all these different types of systems. So this is a picture from District 6 earlier this year when we were still in the office. And unfortunately, the problem is each of these systems is incompatible with other systems. So we could only operate those signals from the specific central system that it was designed to work with. So let's just take a scenario and think about it. So the interstate's closed. We need to detour traffic onto a signalized arterial. Maybe some cows got loose, which is a story I'll come back to. But then we have to think about, okay, what type of signal is it? Is it, brand X, brand Y? And which computer is the one that runs that system? And which seat do I need to sit in? And what are the steps that I have to do in that particular software to accomplish the same thing? And by the time we figure all that out, is the incident even still happening? Or did we take so long to actually even figure out what we need to do that it becomes irrelevant? So PennDOT's solution to this is a unified platform that can work with different brands of controllers and what we call unified command and control. And there were a couple goals of why we did this, which should be fairly self-evident from what I was just explaining. But we wanted to provide neutrality in terms of the controller vendors. So, we don't have to do proprietary bids. We don't get locked into any particular vendor for the hardware that's in the field. And we can also maintain for municipalities that may have a certain preference, we can make sure that they're getting consistent equipment for their spare parts inventory. Obviously, the single platform is a key piece, and we want to be able to respond quickly to incidents, make sure that we can train people effectively and that they only need to learn one system, and that will give us improved situational awareness. Even from a cost perspective, trying to maintain multiple different systems, each one has a support cost and contracts that we would need to be in with vendors to maintain the software and get patches and updates, and our IT staff needs to support all those. And finally, we want a platform that will allow us to measure performance, such as automated traffic signal performance measures. So PennDOT procured the Intelight MAXVIEW system as our central system in 2018. And this is a web-based platform which provides the benefit that we don't need to install any software on individual workstations for the operators to use it. At a basic level, it provides a real-time monitoring and operation of signals that are connected to it. It provides a way to manage the controller timing databases. And it's also integrated with our Open Roads ATMS software that's used in the regional traffic management centers for maintaining all of our other ITS devices. So what it takes for a signal to work with that system is two pieces. The first one is the controller, and at a basic level, that's providing NTCIP compatibility and making all the manufacturer-specific objects available and connected with an Ethernet port. So relatively, all the major vendors at this point have controllers that can do those things. The middle bullet on sharing the MIBs is a little bit more challenging, but I hope that we're going to be able to get there soon. On the communication side, we need an IP address for each controller. We need a bandwidth to support once per second status polling. And when I say bandwidth to support that, we're not talking about a huge bandwidth. I think we figured out that each intersection is somewhere in the range of about 50 to 60 kilobytes per second, so not a huge amount. We need some way to get our IP field network between intersections, so we can have a backhaul that comes in and then have a field network that connects to that and bring it onto the PennDOT network. So there's a couple different paths to get the controllers integrated. The first option is to use a controller that's already integrated into MAXVIEW. The second option would be that, if it's not already integrated, that the controller vendor and Intelight work directly together. In that case, there's some cost potential depending on how that arrangement is worked out between Intelight and the vendor. The other option would be if the controller vendor would provide their MIB objects to PennDOT, and we would then need to work with Intelight to do that integration and determine a funding source for it. And then the last resort is, can we use just a generic NTCIP compatibility to provide the functionality on that corridor with that type of controller? The signals that are currently compatible with MAXView are Econolite, Intelight, some of the 2070 software, and also most recently is Siemens, version 5 and above. The fourth dimension D4 is in process. There's some discussions ongoing with McCain to get their Omni software integrated. The TrafficWare controllers are looking at trying to confirm whether the generic NTCIP compatibility will function. And the only one that we do not have a plan for is Peak at this point, and we have talked to them, and they just said that they were not interested, and I think they've focused on other markets. PennDOT issued a remote communication policy back in 2016, and this just kind of shows a schematic of those types of connections. But what I want to focus on now is some methods for providing that backhaul communication. So, we want to make sure we're doing it in a way that follows the policy, but we also want to make sure we're doing it in a way that will minimize those ongoing communication costs. And I'm sure that anyone that's worked with municipalities on signals knows that there is not a strong desire to continue paying for those ongoing costs at the municipal level. Back when we did a lot of closed loop systems in the 90s, we had problems with the phone lines getting disconnected because the municipality wasn't actively using it and stopped paying the bill. So we want to take those into account, and then finally making sure that we have a secure network and secure the field devices as well. So one of the options that we've identified is connecting to a PennDOT ITS device. CCTV would be preferable, since that would probably have more bandwidth than some of our other devices. If there's any PennDOT-owned fiber nearby, that can be an option. Establishing a cellular communication or providing some other source of municipal procured internet drop. Obviously, that's going to have some additional ongoing costs to it. We've talked to IT about trying to find ways to securely share the internet connection that a municipality may have if the signals are brought back into a facility they have that already has an internet connection. And then if we need to establish a new MPLS connection, that would be a last resort, because that can be very costly. So the example here, this was a project in District 2, and we were trying to figure out whether we could connect these signals and have line of sight with radio communication from a CCTV. So a lot of times the easiest way to figure this out is to talk to somebody in the TMC. So I talked to Jim Roman in District 2, and I was like, hey, can you take this camera and spin towards the signal and zoom in? And he did that while I was watching it remotely, and we managed to find the signal. It's kind of hidden there. It's a very old signal, only one overhead mounted signal before it was upgraded. But because we could see the signal, we knew that we would have good line of sight to provide a radio connection between the signal system and the CCTV site. Another option, this was in near Huntington in District 9, and we had some signals that were connected with broadband radios, and just provided a Comcast business internet with a Cisco VPN that followed the PennDOT IT policy and provided that way. So there's different methods to do it, and certainly if anybody is interested in doing this but isn't sure what the best method is going to be, feel free to reach out and contact us, and we'd be happy to help look at alternatives. Another piece that I mentioned is detection. So every detection zone that we have at a traffic signal is essentially a permanent count station at every intersection. And there's a lot of places where we have those permanent count stations now, but we're not collecting the data, and therefore we're not able to use it. And unfortunately, the equipment in the field really can't store a significant amount of that data. So we haven't been able to go back and say, well, what was this like last year? What is it like now? Even if we went out to the cabinet to try to pull that data. So this is where trying to connect the communications and the detection is important. But understanding that, there's, in addition to just the count information, we can also get a lot of performance measures for how well the signals are serving vehicles. So we have detection that's at the stop bar. We have advanced detection. We can even use detection on the exiting lanes to potentially predict when the platoons are leaving that intersection and when they may arrive at a downstream intersection. When we look at detection, it's important to consider the accuracy and the different scenarios under which it'll operate. We have all 4 seasons in Pennsylvania. We have a lot of snow, we have rain, we have fog. So all those are important to consider in terms of what environment the detection is going to need to operate in. Some of the newer technologies provide the advantage of having one sensor that we can define multiple zones. So if we have a sensor that's pointing at an approach, we can just draw additional zones and capture new information without having to invest in any new hardware. And can we get to some detection that moves beyond a binary on and off? And I'll talk a little bit more about that next. And finally, recognizing that signals are serving various modes of transportation. Traditionally, we focused a lot on vehicles, but pedestrians and bicycles, the way that the signal serves them, if the delay is too long, they're going to make unsafe choices. And if we can know when they're there and make sure that the signal is able to serve them properly, we can make a big improvement. And on the pedestrian side, we've really seen, in some cases with COVID, we don't want people going out and pushing a button to request service. So it's a good opportunity to start to do some R&D and come up with better technologies for those detection purposes. So this is a snapshot of what detection often looks like now. So we have just an on or off. Is there somebody in these little boxes, and everything outside of those boxes is blind to us. But can we get to a point where we actually know information about individual vehicles? What lane are they in? How far are they from the stop bar? And how fast are they going? And there's detection that can do that now, and we're just not leveraging all those capabilities. So how does all this help? And how can this help us with the pandemic and even beyond? And I would say one of the first things to think about is, how can we start making decisions when we're installing signals, when we're upgrading signals? How do we install smarter signals? So the key pieces to that are a controller that can do the high resolution data collection. So that way we're leveraging that count station that we have at the intersection. Having stop bar detection in each lane will give us information to help figure out phase utilization and see if the timing is effective. If we have advance or exit detection on the major approaches, that'll give us good volume data and help us figure out if vehicles are arriving on green and we're providing good progression. And finally, providing that central communications back to our MAXView system will allow us to use these features and do so much more, even if we're sitting stuck at home and can't actually go out and do things the way that we traditionally have. So what does that give us the ability to do? 24/7 volumes. So just thinking about, we talked about the 4 to 6 and the typical day. Well, if we have permanent count stations at the intersection, we can find out when there's seasonal variations. We can find out when there's variation, how much is the pandemic affecting traffic at this intersection? And how quickly can we then adapt to whatever the new normal is? We can do automated traffic signal performance measures. We can figure out how well do our signal plans work? Can we optimize the timing plans? And can we measure performance of the optimized plans or keep tweaking? And finally, can we manage traffic during an incident? So I'll just do a quick example here to wrap up. This was a case where we had an incident that occurred, and closed a freeway, kind of similar to that example I gave before. And we were lucky that we had a lot of the signals connected to MAXView on the detour route, and we had plans that were in those controllers to do it. So we had an incident, and the timing of this actually worked out pretty well because it was after the PM peak, so the traffic volumes were a little bit lower and gave us an opportunity to test out how well this worked. But the incident happened around 7:30. 10 minutes later, the highway was closed and everybody was detoured off of the ramp. And as we started looking at can we do the timing thing, this was not something that we really had all queued up. It was sort of a, hey, this is actually happening where we have the ability to do it, and let's do it. So in about 20 minutes, we got the timing plans implemented, and kind of what we saw from that. So we had a little bit of time when the incident was diverting traffic and we were not doing anything with the signal timing. And we can see that on the off ramp where everybody was diverted, the occupancy, so what percentage of the time is somebody sitting at the stop bar, and they can be that was almost 100% before we changed the timings. Even after we changed the timings, we weren't able to completely flush out everybody that was coming off the freeway, but we were providing over 5 times as much green time. And as we start to look into what did that do downstream, well, I mentioned the incident was diverting people before 7:45. So the volumes downstream on the detour route really weren't changing. So we had a little bit of an increase, but not much. Once we changed the timings and put in the flush plan to really start to move people along the detour, the volume spiked up. And that shows that we actually can move traffic more effectively through a detour with good signal timing. It's also important to look at, is this going to impact people on the side street and cause more delay? And the good news is the side streets were still gapping out, even though they had less time dedicated to them. And finally, the ultimate goal of this, and this is something that Ryan was really instrumental in helping to build with our ATMS software, is being able to activate these plans with one click. An operator in ATMS that doesn't know anything about signals, they just get a description that says, I have an incident, it's going to detour traffic on these roads, and click the checkbox, hit run, and the signals all retime themselves in the background through MAXView. So this is actually a shot from last night. I mentioned some loose cattle. Right as I was finishing up the last session last night, I heard there was an incident in the same location again. So we got to do another example. Unfortunately, I didn't have time to compile all the data and see how well it worked, but it was actually during the PM peak, so it's probably going to look a little bit different. So thanks for joining today, and can answer any additional questions that have come in.
Steve, one question. Is there software available to use for signal performance measures from intersections to have holiday timings?
So I think there's a couple different ways to look at that. Our MAXView system that I mentioned does have the capability of using signal performance measures. And if we have all the detection configured to provide that data back, we can look at that and say, okay, on a holiday, our volumes are a certain amount different than what we would see on a normal day, and we could make adjustments to account for that.
Okay, looks like one more question here. Who will be the responsible party to implement the timing plan changes as you were describing in the incident example?
So that would occur through the traffic management centers, and we are working on building a policy to define who makes that decision and ensure that it's done for the right reasons and so forth. But that would all most likely occur within the regional traffic management centers.
Okay, that looks like all of the questions that came in. So let me thank the two of you for presenting good information. Appreciate it. Thanks to everyone for participating in the safety conference. I hope you got a lot out of it. And I guess that's it. This is the last session, so enjoy your weekend. Thanks, everyone.